All right, let's talk about how these flow rate questions work. So we got people entering a line for an escalator at a certain rate, r of t, given by some crazy polynomial for the first 300 seconds. R of t is measured in people per second. T is in seconds. People are getting on the escalator, of course, by r, and then they're exiting the line at a constant rate of 0.7 people per second. So there are really two rates here. The function that people are entering, and then the constant rate of 0.7 that people are leaving. And there is an initial condition, which there almost always is, of 20 people in the line at t equals 0. So let's kind of go through the questions. Part A. How many people enter the line? Okay, well, that's the accumulation of the rate at which people are entering, right? R of t gives us how many people are entering per second, so we want to accumulate that. So we're going to integrate that rate from 0 to 300, and we get 270 people, okay? And again, this is R of t. Part B, during this time interval, there are always people in line for the escalator. How many people are in line at 300? Okay, well, 20 is what we started at. We accumulate this many, which is 270, for the first 300 seconds, and then we know that 0.7 people are leaving per second for 300 seconds. So the 0.3 times 300 is how many people are leaving the line, which ends up being, or exiting, that negative 210. So it's start with 20, accumulate 270, lose 210, end up 80 people in line. Again, I'm doing my best to use units. These questions always love to use units. Okay, part C. What is the first time t there are no people in line for the escalator? Well, we already know part B says there are 80 people in line at 300, and it said there are always people in line for the first 300 seconds, so we don't have to check any of those. Pretty much, and we also know that we have people stop entering the line at 300 seconds because once it gets to 300 seconds, we're at a rate of 0 for entering. So really, all we need to do is get 80 people to exit. So we get 80 people and divide by 0.7 to find 114 seconds it would take for the 80 people in line at 300 to leave. So the actual time is 414 because we're already at 300 seconds. Okay, makes sense? And then part D, at what time is the number of people a minimum? Again, they love to ask min and max questions on this one. This one it says round to the nearest whole number. Okay, so every single time, please do a chart. Every time. The AP does it every time. You should do it every time. When they ask for a min or a max, you're going to do a chart. Again, reminder, we find mins and maxes by looking for when f prime is equal to 0, or endpoints, or f prime doesn't exist. F prime almost always exists in story problems, so we're really looking at f primes equaling to 0 and endpoints. The f prime is the total rate. The total rate is the rate entering minus the rate leaving, and we want that equal to 0. That occurs at two different times. At this point, 33.013 and 166, round to 3 decimal spots. And now we're going to do a chart to display the data. The endpoints are 0 and 300, and our other critical points are 33 and 166. I'm going to find the number of people in line at those moments. Now, I already know the 20 and the 80 from previous parts. But I basically got to do this same calculation. I got to accumulate, or actually I'm doing basically this calculation. I'm going to accumulate from 0 to 33 and add 20 and figure out how many people are in the line at 33 seconds and do the same thing at 166. Show them that you have this chart. These are the only locations, the only times that could be a min or a max. And then we're like, oh, look at that. That's the minimum, 3.8 people. So our conclusion to the whole person is that there are 4 people in line at that time, and that is the absolute minimum that occurs. Again, these questions are all about accumulating rates, looking at maxes and mins, maybe even points of inflections, which it didn't ask. Make sure you use initial conditions, make sure you use units, and things like that. Okay, that was actually 2018. Let's do 2017 now. Similar, except this one there is actually 2 separate functions instead of one function and a constant. So this is the rate at which Customers are removing bananas from a display, and this is where the store employees are adding bananas. Okay, and this is in pounds of banana per hour, and T is in hours. And there are 50 pounds of bananas to start. So again, they always do stuff like that. Is there any other detail? Oh, after the store has been open for 3 hours, then they start adding bananas to the employees. So this happens for 3 hours, and this waits. And so if you even just look at the kind of domain of the time, it'll kind of tell you that. Okay, so part A, how many pounds of bananas are removed from the display? Okay, that's just accumulating the removal rate for 2 hours. We're going to integrate that on our calculator and get that. Okay, and again, it doesn't say round at all, so we always go to 3 decimal spots. All right, find f prime of 7. Okay, that's just taking the derivative of this guy, and your calculator can just take the derivative. That's what I mean by use your calculator and enter. And that's the rate at which bananas are being removed is decreasing by 8.120 bananas per hour. And again, it wants to use units, right? Remember, this is in bananas per hour, so the rate, the derivative of that is bananas per hour. It's kind of like an acceleration. You could say bananas per hour squared, but I would suggest doing it bananas per hour. C, is the number of pounds of banana on display increasing or decreasing at t equals to 5? Okay, well, if we want to know whether the number of bananas are going up or down, we got to compare the rates of the bananas being removed and the bananas being added. So if you look at g of 5 minus f of 5, right, that's added minus removed, and it's negative, meaning the number removed is more, right? So we're saying that this rate is below 0. The number of bananas is actually decreasing, okay? And again, you got to numerically tell them that to support this. And part D, how many pounds of bananas are on the display at t equals 8? Okay, so the careful thing is you got to be careful about time. Remember, bananas aren't added for the first 3 hours. So you're going to start with 50, add from 3 to 8 the bananas added, and subtract from 0 to 8 of the bananas removed by the customers, and then you end up with 23.347 pounds of bananas. Okay? So these are the probably 2 kind of poster childs for the flow rate questions. You got maxes and mins, where I did a chart. You got different rates. Sometimes you're doing derivatives and explaining things. They're all big on units, but hopefully these 2 kind of give you an idea of what I mean by the flow rate. And in class, you're going to do a whole bunch more of these examples.